Good afternoon, everyone. My name is Craig Rydell. I'm the Vice President of Technology here at Kron. And today I want to talk to you about why NAC isn't enough and why we need to bring PAM and identity aware controls to the network layer. But I want to set the tone here. This isn't going to be us bashing on NAC. NAC certainly has its job and it's doing it just fine. But we're blind once the session starts. We've done a great job in bringing identity aware controls into cloud and infrastructure layers, but at the network layer, identity control often stops at the door. Today is about closing that gap. I want you to take away a few things from this discussion today. Why the network layer behaves differently from endpoints and applications, where NAC ends and PAM begins, what session identity and command control means on routers, switches, and firewalls. But let's start by grounding this identity blind spot that we'll all see during audits. All right, so as I talked about, today we want to highlight the identity blind spot in network security. So NAC authenticates devices and users at the time of connection, but it does not talk about what commands users ran. It doesn't limit privilege on the CLI or record what happened. At the network layer, shared accounts and static keys are still very common. Very good for uptime and shared tasks, but terrible for security. And without session identity, it's impossible to answer the who changed what and why. So for CISOs, this is a real accountability problem, and it becomes an audit and incident response problem as well. This should tie into our standard forensics playbooks, keystroke logging, and things like that. But because at the network layer, it's hard to deploy agents or often impossible to deploy agents, we just often have managed credentials. We need to go beyond that and apply these same identity-based controls to the session. Let's talk about a real attack here, Salt Typhoon. Network equipment is a really valuable beachhead. When it's exploited, shared keys and weak session controls can really amplify impact. This attack chain was quite simple. There was a few couple of known exploits on Cisco equipment, and then they leveraged SSH key reuse to move laterally through the environment, eventually elevate privileges, and then gain access to PII and exfiltrate that data. When you start to talk about shared keys and the ability to move laterally through the environment, it's also important, I think, to highlight it's a very low noise method to move around for attackers and often bypasses security controls. So not extending this identity control, managing the credential, but also what goes on inside of these sessions and attributing that all of that to a user, not just a shared account, is a real blind spot in our overall zero trust strategy. And I think auditors and regulators are starting to catch up to this. Let's talk about the compliance needed for PAM. Most frameworks today expect strong identity, least privilege, and auditability across all infrastructure. I believe this should include network devices. If you look at NIST or ISO or NERC there's always a tide to identity. And the auditor quote on this slide, I believe, sets the tone. The inability to verify who did what is the recurring finding here. This is not just a need for security auditing, but it's also a need for audit readiness and I believe a gap again, when you start to have to treat environments as one-offs, we need controls that can span across the entirety of our identity threat landscape, and network has been left behind. So, just a couple of things I want to really hammer home before we jump into the demo here is NAC does its job. It controls the door, but PAM secures the session. Together, they deliver identity at connection and control during the session. While NAC certainly has its strengths, posture assessment, network administration, VLAN, ACL placement, etc., it does not target per command authorization or per user session logs, just in time credentialing, or any of the other things that we would expect out of a PAM solution or an identity first approach to security here. Kron Network PAM complements NAC by offering all of those same things: just in time access to accounts, removing standing privileges, no needs to install agents, per user mapping to shared accounts, command filtering, so whitelisting and blacklisting of commands, uh, risk based or step up approvals for risky action. Of course, session recording with searchable logs. Um, and all of this can be deployed across whatever your infrastructure needs are, whether it's SaaS based, on prem, a mixture of both, a true hybrid deployment. And again, like I said, without the need to deploy agents. So we're going to jump into a demo here and just show a little bit of how Salt Typhoon attack chain worked, and then where PAM solution can jump in and help mitigate that risk. All right, so now that I've switched over to my demo environment, I'm going to kind of walk you through the attack chain of Salt Typhoon. And this demo is probably going to seem a bit repetitive or high level because these are the exact same concepts that we're using in our cloud environments and our server IT environments. Like I said, we're just extending it out to the network. So what we'll show here is just the initial foothold. Um, Again, Salt Typhoon heavily relied on shared SSH keys. So just simply showing an exposed SSH key with a reusable credential gets me into the router. And this is the same pattern that we've seen throughout this entire attack. Um, and then we'll kind of get into how we would block this after we enable PAM here in just a minute. So we've onboarded our router now into the PAM solution. So let's take a look at what that looks like before we try to access using our stolen key and our original access key. So if we come in here, we can see we've just added this router in, accessing over SSH, Cisco IOS switch, and then we'll just go ahead and take a look at the access now. And like I said, this part of the demo is pretty straightforward, as it's really just showing that we're controlling access to these SSH keys now. So let's take a look. Let's start with our original access key, which was just our lab key. And then let's do the same thing, but try our stolen key just to check. But then what we'll see whenever we switch back to our cloud access node is that those keys will actually work. So let's take a look at the stolen key here first, going out to the cloud node. And we're in. And then let's take a look at the original lab key here as well. And we're in again. So just going to show you, managing SSH keys is the initial way to stop this type of attack, and then we'll move on to the next phase. So once an attacker would get in, kind of the next part of what would happen would be they would go out and search for other SSH keys and try to gain access to those. And that's really what makes campaigns like Salt Typhoon so effective and so quick, is that one key really unlocks many systems. So we'll just kind of go through and take a look at what this looks like, and then copy these keys down. And now we can just confirm that we have that key, and we do. So once we enable cron here, what you'll see is that these static SSH keys die. We'll start to get into management and credential rotation, either on demand, um, or based on your own internal policies. It could be every single time the key gets used, it's destroyed and then kind of generated on demand or just in time, depending on what your own internal policies are. Okay, so we've already stolen SSH key from the router, and in most environments, these static keys are reused everywhere. So let's see what happens when I try to use that to move laterally. Now, here I am on the router using my original lab key, which was the attacker's initial access point. And then I'm going to attempt to move laterally out to a cloud node. Now I switch to the stolen static key, and without needing a password, without needing MFA or any approval, I'm on the cloud host. That's lateral movement in a nutshell. So we can show this weakness explicitly. And the one thing to notice here is that I immediately inherit full shell access. Nothing stopped me. No logs would clearly tie this back to any real user. And that's why SSH keys are so dangerous. And as this attack showed, very, very often still used and shared because they're tied to a lot of automation in our environment. Now we'll enable Kron network PAM and take a look at how we can stop lateral movement. So I was really trying to visualize a way to show how to stop lateral movement beyond just what we've already shown with the credential management, the SSH key management. So I figured what I would do is actually just come in here and show you a bit more on the configuration screen. So we currently have onboarded our new cloud instance here. So that's what we'll show in just a second, the credentials being blocked. But we've set this up to be a dynamic account using SSH keys. Same thing in our demo lab. Um, and what that means is we're just rotating these keys every time they're being used. So our old keys, similar to our other attack, they'll just be blocked here. So when we come back up here and try to access the cloud instance now, whether it's with the stolen key or with the old lab key, you can see that it gets blocked. Exact same concept that we're doing before. So every single time a user is logged in, they check out a key, it gives them access to it just in time of their session. We can tie this into your ITSM for change control verification and anything like that. But as soon as the session window is no longer in scope or the session is terminated, the credential is destroyed and it's no longer there to be abused. So far, I've gained a foothold on the router, stolen a key, and used it to move laterally into the cloud node. But as an attacker, I don't just want user level access, I want root control. So on this cloud node, what I'm going to demo here is that sudo is available. And because there's no just-in-time privilege control or manager approval process, I can just simply run it and immediately elevate my privileges. So why does this matter? Escalation is a turning point. I'll now own the box. So let me just go ahead and grab this. And you can see that I could gain root level access here. In the Salt Typhoon attack, this is really the stage where attackers begin moving with confidence because once they had root, every barrier downstream was weaker. From here, I could do things like add or remove users, change configuration, disable logging, and basically give myself persistence. So notice how this looks almost identical to what we do in our cloud and IT environments, but because we can't install agents here, this privilege jump is happening without any oversight. This is exactly the gap that Kron is designed to close, and I'll show you that when we switch over to the Kron console and then try to run this again. Okay, so we've talked a lot about credential management, SSH key management, stopping lateral movement. But if we want to take that the next step further, we believe that you should only really need to know your password to what you log into your laptop with in the morning. All the other credentials for any other shared account or privileged account or anything else that you have access to, once your user account's fully authenticated and authorized to connect to the endpoint, you have approved change control, then the credential is injected on your behalf, and it's never made visible to the end user or anything like that. So let's take a look at what that would look like now that we have onboarded both of our instances, and we've got a test user, Jared Black, who is going to go out and connect to our um, cloud endpoint. Okay, let's take a look at what it looks like when we log in for Jared. And we can see that once we've logged in here, we can take a look at all the servers we have access to. Let's go ahead and access the Salt Typhoon cloud server, the same one we've been accessing. So we've shown how to stop lateral movement, credential management, SSH key management. And now let's just take a look at some simple command restrictions. We have a simple demo here to block the sudo command. You can see it's blacklisted, but let's take a look at how we do that in the console really quick. Okay, so if we go over to our Kron console, we can see that we have a few different black keys here. So here's just a quick and simple demo. We're just blocking anything with sudo, and then we're applying it to this role. And we're just simply saying that whenever this happens, we're going to block it, we're going to generate an error, but we can also do ticketing workflow, double confirmation, geofencing, manager or SMS approval to approve the command. And in our upcoming release, we'll actually be able to do additional MFA prompts here. Okay, for the last part of this demo, I've actually built out a database, and we've assumed we can block the static SSH keys, the just-in-time elevation.
So here we have
privilege.
Similar to before,
But what would happen if
onboarded
all of
our
those controls
Postgres
failed
database
and they
and
were still able
defined
to
some
gain
policies
access to
for
the
it.
database?
So
What you'll see in this
we
next
can
part of the
see
demo
that
is
we're
our
allowing all
dynamic data
commands,
masking, to
but
where we
blocking
can
anything with a delete
obfuscate
cause,
PII in
and
real
then doing a
time.
masking
So even
policy
if an
for
attacker did
addresses
get access
in
to
the
a
employee
database
address
there,
field in this database.
they still wouldn't be able to
And
pull
now
out the sensitive information.
let's look
It would
at
be
what that
obfuscated from
connection
them
looks
based
like.
on their role and auditing level.
So just humping over to our PG admin tool here, I've set up two connections, one direct and one through the PAM server, just so you can see what it would look like in both. Here's the connection. And if we go down here into the employee table and view it, we can see everything. Now, if we go up here to our onboarded instance and do the same thing, come down to the employee table and view this. Now we can see the address field has been obfuscated from view. It'd be the same thing if you're doing this through a CLI, but this just shows a little bit better for the demo.
Okay, so just switching back over to the slides here, what we just saw was the Salt Typhoon attack chain in action. This starts with something simple, as we saw, a stolen or shared SSH key or credential. From there, the attacker uses that key to laterally move, harvest more credentials, and ultimately reach sensitive systems and data. The reason this works is because network devices often rely on static keys, shared accounts. Unlike our IT or cloud environments, where we can install agents, we can't do that. It's harder to enforce MFA. And that gap is exactly what we at Kron close. When we enabled Kron PAM at each stage, the attack broke down. The keys were no longer static. They were rotated on use and tied back to a real user. Attempts to harvest or reuse keys failed because by the time they were copied, they were already invalid. Lateral movement was cut off through just-in-time access, session approvals, and command-aware controls. And then lastly, even if an attacker did reach sensitive data, dynamic data masking ensured that they couldn't see or exfiltrate any sort of customer records. So the big takeaway from this is really that these aren't new techniques. They're the same tactics attackers have been using everywhere. What's new is really bringing the identity-first controls into the network layer where they've traditionally been overlooked. And that's where we at Kron play well. We fill that gap. But let's ground this in something real. We have a public reference customer, Turkcell, who has deployed our network PAM solution at scale at over 300,000 devices across their network, on-prem, and cloud assets, 160,000 privileged accounts. They have this deployed in a multi-tenant fashion and have massively improved their automation. What we did beyond the cybersecurity side of things is we also removed control silos between network operations and security, which vastly improved not only their audit posture, but their audit prepare time. And then from the security lens, we gave them a consistent policy-enforced, identity-first practice that they could extend across all of their environments. And improved a lot of automation here. So one thing we haven't really covered is all the things that you have seen inside of the Kron PAM have a corresponding API call. So a lot of our customers use this to increase their identity maturity, to offer a lot more automation and user self-service. And that's really what I want to ask on the back of this kind of customer case study is, where would automation and onboarding save you the most hours in your day? But let's double click on visibility and insider risk as we wrap up this presentation. As we all know, not everything comes from the outside. Audit visibility and insider risk is a real concern. What we really need to focus on here is the per user tagging command controls. Turn shared accounts into accountable activity. So even if you weren't to remove all of your shared accounts throughout your environment, you would be able to see, for example, that it was Craig accessing this account, running these commands at this time. And then we can still get into doing things like anomaly detection, user behavior analytics, making sure that things are tied down to approved change control, step-up authentication through multi-factor authentication, basically just a lot of different ways to prove that you are you and stop a lot of the insider threat, even if there was credentials that were harvested through a phishing campaign or malware like we just saw or a vulnerability like we just saw in the Salt Typhoon demo. There's layers of defense here all wrapped around the identity. But really, it's not our job to just be pure security practitioners anymore. It's really only half the value prop that we have to tell. Let's get into a little bit more about how Kron can help with operational efficiencies. It's not just enough today to talk about the security side of things. We also have to think about the operational side of things. So that's why at Kron we have an agentless approach. We know the last thing you want to do is go out and install another agent, manage it, update it, patch it, deal with the agent tax on the endpoint. And there's some environments that, as we just discussed with the Salt Typhoon attack, there's not an agent that's available to be deployed. That's why we go with an agentless approach. Not only does it speed up time to value and lower total cost of ownership, but it also just makes the end user experience a lot more pleasurable from what we've gathered in our customer feedback. We've had customers who report large reduction in audit prep time because the evidence is centralized and searchable, fewer emergency change windows due to approval workflows and pre-change check controls. Things like that is where we start to bridge the gap between the security team and the operational team, getting into other things like automation, where we can work with other parts of the business to really kind of round out the rough edges. And provide a higher degree of user self-service. removing the bottleneck oftentimes that people or processes create, and allowing things, as long as they're inside of your security guidelines, to move at the speed of business. So just a couple of things I wanted to leave you with before we wrap up today. Download our white paper, Beyond NAC. Feel free to share that with your team or any of your other peers or colleagues. Feel free to write me on LinkedIn and let me know what you think. It dives into the breach a little deeper. There's also a couple of other interesting ones around what we've got going on in Brazil with the PIX incidents and stuff like that. We're also doing enablement, so like some assessment type of work. Happy to jump on a call and talk about any of these things in more detail, whether it's a technical use case or a compliance framework you're trying to align behind. Or if you want to get early access into our proof of concept models to just test these against your existing frameworks, happy to reach out and answer any questions that you all might have. And just because I know this one is going to go out as a recording a little bit after the webinar, just a couple of things I want you to think about as we wrap up today. So, how are your shared credentials handled today? How are you doing network device authentication today? Or do you have any device families that are particularly hard to audit? And last but not least, what command level policies would you enforce first if you had them tomorrow? Thank you all for taking the time to go through this with me today. And like I said, if you have any questions, feel free to reach out either email or LinkedIn, and look forward to connecting. Thank you all. Look forward to connecting. Thank you all.